For this example, we've been asked to calculate all of the second derivatives of the function z, which is equal to x squared y cubed plus e to the xy. So the first thing we need to do is calculate both of the first derivatives. So that is the partial derivative of z with respect to x, which is equal to 2x y cubed plus y e to the xy. And that comes from differentiating with respect to x and treating y as a constant term. We also need to calculate the partial derivative of z with respect to y, and that gives us 3x squared y squared plus x e to the xy. So these are our two first derivatives that we will use to calculate the four second derivatives. So the first second derivative is the partial derivative with respect to z, which is differentiated again to get d2z by dx squared. So that is differentiate all of this with respect to x again. So that gives us 2y cubed plus y squared e to the xy. We also need to calculate d2z by dy squared, which means differentiate this with respect to y. So that gives us 6x squared y plus x squared e to the xy. So now we need to calculate the mixed partial derivative, that is the d2z by dx dy and d2z by dx dy. So this means take the first derivative with respect to x and differentiate it with respect to y. So that gives us 6xy squared. Now we need to use the product rule here. So we get plus e to the xy plus xy e to the xy. And we can simplify this a little bit. We can just factorize out an e to the xy out of these two terms to give us 6xy squared plus 1 plus xy e to the xy. Now moving on to this final second derivative, it just tells us to take the partial derivative with respect to y and differentiate with respect to x. So that gives us 6xy squared. Now we need to use the product rule on this term here, so that gives us plus e to the xy plus, now we need to leave this term alone and differentiate this one, so that will give us a plus xy e to the xy. And so again we can factorize out e to the xy and we'll get 6xy squared plus 1 plus xy e to the xy. So we've calculated all four partial derivatives, second order partial derivatives, and we will see that d2z by dy dx in this case is equal to d2z by dx dy. Now this isn't always the case, but it is true for this example.